Hello and welcome to Physics Platter. Today in Physics Platter we will have a basic discussion on the graphical representation of motion. So we will be talking about the motion, means the state of the motion, if a body is at rest or uniform motion or non-uniform motion, how we can represent these things in terms of the graphs. And to draw the graphs we will be using the basic variables of kinematics. All right, and the variables are, as you know, the displacement, velocity, time. All right, so let's start. Let's first write down the variables. What are the variables here? Variables are displacement, that we will be writing as S, generally written as S. S1 for the initial position and S2 for final position or something like that. All right, and then velocity, which is represented as V, and V1 for initial velocity, V2 for final velocity of a body, and then of course the time as T. Okay, so these three variables are to be used for the graphical representation of motion. We have seen one thing, that as you see, time is something that is everywhere, that is kind of common in all the variables. If you represent displacement, you have to talk about the position of a body, position at an instant of time, right? So there is also time. Then velocity is what? Velocity is the rate of change of position. So basically the final position minus initial position divided by the time interval. Okay, and then of course there is another thing, which is acceleration, which is A. And then acceleration, we know that rate of change of velocity, means final velocity minus initial velocity divided by the time interval. Okay, so these are the variables, these are the four variables we will be using. As if you have seen my previous video, my video on the graphical proof of the equations of motion, you can see there they are also called SWOT. Okay, but you use the initial velocity, we use the final velocity. All right, so let's go. To represent anything on a graph, we need axis. Generally, what we know, that we use x-axis and y-axis. So x-axis, which is the horizontal axis, this is the origin, and y-axis is the vertical axis. All right. In this, instead of the x and y-axis, when we talk about the motion, we will be using these variables. And whatever graph we draw, time will always be on the x-axis. Okay, remember that. And then if we talk about the displacement graph, then with the displacement time graph, then displacement will be on the y-axis. If we talk about the velocity time graph, then velocity will be in the y-axis, and then acceleration time graph, that will be acceleration will be in the y-axis. All right. Then we will be talking about three things of motion, as you know. First thing would be the body is at rest, how the graph would look like, and then second thing would be the body is at uniform motion, and then third would be body is at non-uniform motion. So these are the things, these are the three situations we will be talking about. All right. Okay, so let's first talk about the displacement time graph. Displacement time graph, which is also written as ST graph. ST graph. As I told you, in any motion graph, the time will be in the x-axis, represented in the x-axis. This is my time axis, whereas the y-axis will be representing the displacement here. So this is the displacement time coordinate system. All right. Okay, now first thing, the body is at rest. What does it mean? The body is at rest means what? When the time goes on, with respect of the time, the body is not changing its position. It's always at the same position for same interval, so for whatever interval of time, right? Means what? If this is positive, of course, positive axis, this is negative. So whatever time we go here or there, whatever interval we go, the body remains at the same position. So if it was at 0 position, then it would always be at 0. So it would look like a straight line going to the time axis. If it was at somewhere here, let's say S1 position, then it would always remain in the same axis forever. Alright, means even if the time increases, the position of the body S does not change. This height does not change. The body remains at the same position. So this is my rest position for a body, which is represented in the displacement time graph. Now, if the body, this is rest, how does it look if the body is in uniform motion? All right, so let's say 0. Uniform motion means what? Of course, displacement here and then the time here in the x-axis. Uniform motion means for an equal interval of time, the body travels equal distance. Wherever the interval be, for that same interval of time, body always travels the same distance, and the graph would look like something like this. So it would start from 0, let's say, then a straight line. What does it mean now, this straight line? See here, when the time changes along the time axis or x-axis, for the same value, the displacement also increases. Okay, and equally, for the equal interval of time, the displacement also changes equally. For this interval of time, interval of displacement would be the same. Okay, so this is the uniform motion of the body. Now, when a body moves in a uniform motion, what happens to its velocity? Velocity remains constant, right? The velocity of the body remains constant. From the graph, how will I find the velocity? And how can I say that the velocity is constant in this graph? Alright, now we will introduce another term which is called slope of a graph. Slope of a graph. Let's say at this position, this is my let's say this is my T1 and this is my T2. Alright, and corresponding displacements for T1 is S1 and corresponding displacement for T2 is S2. Alright, so what it means, at T1, first time, which comes first, the initial position of the body was S1, and then when the time goes to T2, the body moves to the position S2. Now, what happens to the velocity? Velocity means what? Velocity is nothing but the change in the displacement, final position minus initial position divided by the time interval, right? Or we can also write del S del T. Alright, now see here, this is velocity, of course. Now see here, del S del T. What does it mean? Del S means the difference in the displacement or difference in the position, and del T is the difference in the interval in the time. Now if this is the point and these are the 2 points at T2, T1 and T2. Now see, this forms a triangle, right? If we extend this line, horizontal line, then it forms a triangle whose this is my del S and this is my del T. This is the interval of the displacement, difference in the displacement, and this is the interval of the time. Now del S del T means what? Del S divided by del T. This is a right angle triangle, right? If this angle is theta, then this del S by del T is nothing but the tan theta, right? So tan theta equals to del S by del T, and this tan theta is called the slope. Alright, so slope is nothing but the tan of the angle of the graph with the x-axis. Alright, so slope equals to tan theta equals to del S by del T equals to what is here? Velocity. This is a very important point. That means the slope of a displacement time graph represents the velocity of the body. Alright, simple as that. The slope or the tan theta of the displacement time graph represents the velocity of the body. Alright, make it clear. Okay, so this is my uniform velocity. So here theta is always constant, be it here also angle is constant, here also angle is constant, at all position the angle is constant. That means the velocity is constant. Alright, that means the body is at uniform velocity. Alright, now let's find out this is uniform velocity. Non-uniform velocity. What happens if the body has non-uniform motion? What happens then? If the body moves with non-uniform motion, the graph would look like something like this. T displacement S, of course, the 0 here. The graph would look like something like this. See here, this can be a non-uniform motion, or it can also be something like this. T S 0, something like this. Okay, these are the examples of the non-uniform motion. Now what happens in this graph to the velocity? What happens to the body, velocity of the body for this graph? See here, how can we find the the velocity from this kind of graph where non-uniform, the body is moving with non-uniform motion. Alright, at any point, let's say at this point I want to find the velocity. Now we know that velocity is the slope of the graph. To find the slope at a point, let's say this point is P. At that point, we simply draw, because it's a curve, we simply draw the tangent at that point. It doesn't look good. Okay, tangent at that point, and then something like this. Whatever angle the tangent makes with the x-axis or time axis, tan of that angle is the slope of the body. So simply, if we imagine a triangle and this is theta, of course that also theta, then the velocity of the body would be the tan of tan theta in this triangle. Alright, so what happens to the velocity here? At this point the velocity is theta here. At this point the velocity was, the velocity was something like this. So theta, this angle. At this point, what is the velocity? The tangent is this theta. See here, when the time increases in this direction, the value of theta also increases, right? See, the value of theta looks like this. Let me draw it more clearly. So the graph is this is T0. At this point, come on, theta was this, at this point P, and then at this point, let's say theta looks like this, and then at this point, so this is time T1, time T2, and then at this point the theta looks like this. Now this time T3, let's say. So at T3 the velocity is the tan of this theta. So this theta is more than, let's say this is theta 1, theta 2, theta 3. So theta 3 is greater than theta 1, theta 2, and greater than theta 1. So theta is increasing with the increment of the time. That means the velocity also increases in this time, in this type of motion of the body. which means the body moves with the non-uniform motion. Alright, body has non-uniform motion. What happens in this case? What happens in this case? See, now before going to that, I must tell you one thing, that in this graph, where the velocity is increasing, what is the meaning of velocity increasing? Velocity increasing means what? With let's say velocity is increasing with the time, means the body is accelerating and the acceleration is positive. All right. So here in this kind of curve, the velocity, the acceleration is positive. Velocity increases, acceleration is positive. This velocity increases and acceleration A is positive. Okay, let's talk about this graph now. In this graph, at this point, let's say we'll take 3 points, three times. So let's say this is T1, this is T2, and this is T3. All right. So in these 3 different times, at T1, the velocity was this is my theta 1. At T2, the velocity was this tan of theta 1, theta 2. At T3, the velocity is something like this. That will be very long way. Theta 3. Now see, theta 3 is less than theta 2, less than theta 1. Right? So the angle actually decreases when the time increases in this curve. This is also non-uniform, this is also both the motion of the body are non-uniform motion. But for the first case, our velocity was increasing. From the graph it was clear, from the slope of the graph. From the slope of this graph we see that the velocity is increasing because the theta, the angle, is also decreasing. So the velocity is actually decreasing. Velocity decreasing means the acceleration means negative. In this case, the acceleration is negative, or we can also say the body is decelerating. So retardation is happening. So from these two, we can conclude that in the displacement time graph, let me write here, in the displacement time graph, one very important thing, that time displacement, when the curve is downward, something like this or this one, when the curve is downward or the concave is downward, all right, then the velocity decreases. The velocity decreases means acceleration is negative. Acceleration is negative. Whereas if the graph looks like this, same graph, so the graph looks like this, means the curve is upward. The curve is upward. Then the velocity increases and acceleration is positive. Okay. If you think about a bowl, if the bowl is just erect, kept like what can I say, the curvature of the bowl is upward, then the velocity increases and the acceleration is positive. Whereas if the bowl is upside down, then the velocity is decreasing and the acceleration is negative. Okay, so these are the two things we can conclude from this. All right. Next, displacement time graph we have done. Next, let's move on to, this is over, move on to the velocity time graph, VT graph, velocity time graph. In this case, as I told you, the time is always in the x-axis, whereas the velocity, the other variables, in the y-axis, v. So first thing, the body is at rest. Means what? Velocity 0. Of course 0. Velocity 0 means the motion would simply go like that. Means the curve will never leave the t-axis, and it will follow the t-axis. It will be on the t-axis when the velocity is 0, means the body is at rest. Okay, whatever time it is, the velocity is 0. Okay, body is in uniform motion, means velocity constant, t0 velocity constant means what? Whatever velocity it is, let's say this is v1, this is the velocity of the body. The body is moving with the velocity v1 and it remains constant with the time. It means what? This whatever time interval it is, or whatever change in time happens, the velocity remains constant, means the graph will be parallel to the t-axis. Okay, the graph will be parallel to the t-axis, means what? The distance of the graph from the t-axis will always be the same, means v1. Okay, this distance will always be same. Okay, so this is the body with v equals to constant, means the uniform motion of the body. Acceleration of this body is what? Acceleration is when the v equals to constant, means final velocity, initial velocity are same, means a equals to 0, of course. Acceleration is 0. Alright, acceleration means what? Final velocity minus initial velocity divided by time, or rate of change of velocity. Here no change in velocity means acceleration will be 0. So this is my uniform velocity. Now non-uniform motion. Non-uniform motion, vt time graph. How will it look like? T, 0 and v. Let's say for a non-uniform motion, means the velocity of the body is constantly changing, either increasing or decreasing. So it would be a straight line, but if it's constantly changing in the equal rate, then it will be a straight line, something like this. Alright, if the body started from 0 velocity, it would look like this. This is, now from this graph, what can, this is of course non-uniform motion. Non-uniform motion, velocity increases with the increment of the time, with the increase of time. Now what can you talk about what can you say from the slope of this graph? Slope means what? As I told you, the angle theta, and the angle remains same here, right? In this case, slope is what? Let's say at time t1 there are two times, t1 and t2. T1 and T2. At T1 the velocity of the body was v1, and at T2 the velocity of the body was v2. Then what can you say about the slope of the body? If this is theta, then tan theta equals to what? Of course slope equals to, means what? This is my del v, this is my del t, means what? v2 minus v1 by t2 minus t1 equals to del v by del t. Now what is del v by del t? Rate of change of velocity, means acceleration. That means acceleration, right? Okay, so slope of the velocity time graph represents acceleration of the body. Now for this particular graph, where the graph looks like a straight line passing through the 0, the origin, we can conclude that the acceleration of the body is constant, because the angle remains constant. Angle with the x-axis or t-axis here remains constant throughout for this graph. So acceleration is constant, and the initial velocity at time t equals to 0, the body started from 0 velocity. The velocity of the body at time t equals to 0 was 0. Okay. Now what if the body already had an initial velocity? The graph would look like this. Because the body did not start from 0, t, this is v, here. So the graph would look like this, because this is, let's say, initial velocity u, the normal representation, this. Okay, so the body started from here, that means the body was already running moving with the uniform velocity u before initially, and then started accelerating, and we started counting the time right from there. Okay, if there was no acceleration, the motion of the body would look like this, but because of the acceleration, the motion looks like this, the graph looks like this, and this is the final velocity. This is my final velocity v. Okay, understood? And this is of course the theta angle of the graph, and tan theta is the acceleration. A equals to tan theta. In this case will be v minus u by delta t. All right. So this is also non-uniform motion, and there can be other non-uniform motion, something like this. So if the velocity 0 time v, something with, if it looks like this, what happens to this body? How is the motion of this body from this graph? What can you conclude? From here we can first of all conclude that this is a non-uniform motion. Why? Because the velocity is not constant. In a uniform motion, the velocity would be always constant. So this is a non-uniform motion of the body. All right, first conclusion. Second conclusion, what can you conclude about the acceleration of the body from this graph? Acceleration of the body is a slope in the VT graph. So if we consider few points, let's say P, one point here, T1 at T1, and then one point here at T2, and then let's say another point here at T3. What happens to the slopes for these points? At T1, the slope is, this is theta 1. At T2, the slope is something like this, theta 2. At T3, the slope is this, which is theta 3. Here, clearly theta 3 is greater than theta 2, greater than theta 1. What does it mean? It means that the acceleration of the body, of course, when the angle of the body is increasing, means what? Theta is increasing, means what? Which we can conclude that acceleration of the body is not constant, and it is also increasing, because when theta increases, tan theta also increases, means the acceleration of the body increasing. All right. Similarly, if the bowl is upside down, as we have discussed before, then 0 TV, if it looks like this, then also we can say that it's a non-uniform motion. The velocity is not constant, of course, and then the graph here, in this case theta 1, theta 2, so the theta 1, theta 2, in this case theta is decreasing, which means the acceleration is also decreasing, because the slope of the graph is decreasing here. All right, so from this we can conclude that. Okay, now see one thing. In the velocity time graph, let's say a body is at uniform motion. All right, velocity time graph, the body is at uniform motion, means what? Let's say the body's velocity was v, and uniform motion means a line parallel to that. All right, at time t1, let's say this is v1, the body was moving with uniform velocity v1, and then for time t1, we want to find what is the displacement of the body from this graph. Displacement of the body from this graph. What do you know about the displacement? S equals to, for a uniform motion of the body, velocity into time, right? For in this graph, what is that? V1 into T1. All right. Now, if we consider this rectangle O, A, B, C, let's say this rectangle, if we consider, then for this rectangle, what is the meaning of V1 at V1 into T1? V1 is what? V1 is the OC. OC equals to V1 equals to AB, and BC equals to T1 equals to OA, right? That means V1 into T1 equals to what? AB into BC equals to what? Equals to simply the area under the rectangle, right? Area of the rectangle. Area of the rectangle. What does it mean? It means that in the velocity time graph, the area under the graph represents the displacement of the body. Okay, if a body moves like this for a non-uniform motion, let's say, then at time t1, what is the velocity? What is the displacement? Let's say this is t1, this is v1, final velocity. Then what is the displacement? Displacement again is the, as we know, is the area under the curve. So here, simply from the graph, instead of going to the numeric, algebraic representations, we can simply from the graph we can calculate the area, the displacement of the graph of the body as the area of the triangle here. Area of, let's say, is OAB. So OAB equals to what? Half into base. Base means what? OA means T1 into the velocity AB, the perpendicular, the height, so V1. So half into T1 into V1. Alright. So this is my displacement of the body. Okay. Now let's move on to the last part of the lecture, which is acceleration time graph. Acceleration time graph. Acceleration time graph. So first, the body is at rest. Of course, in the acceleration time graph, the time will be again in the x-axis and acceleration this time will be in the y-axis. For the body at rest, what is its acceleration? Of course, when the body is at rest, v equals to 0. When v equals to 0, a equals to also 0, means again the straight line through t-axis. Alright, represents the straight line through the t-axis. Alright. Next, the body is at uniform motion. Uniform motion means what? Again, the acceleration is 0. Right. That means 0 t acceleration. Uniform motion means what? Uniform motion means the velocity equals to constant, means acceleration equals to 0. Means again the graph would look like this. Simply the line through the t-axis. Alright, the graph will coincide with the t-axis. That means from the velocity time graph, from the acceleration time graph, we cannot conclude about the body is at rest or uniform motion, because in both the cases acceleration is 0. Alright. Now non-uniform motion. Non-uniform motion means what? When the body is constantly changing its velocity. So acceleration time 0. So if the acceleration is constantly changing in the equal rate, the graph would look like this. This is a non-uniform, and then also it would look like curve, this, or can be this also. Okay, 0 t acceleration can be this also. Now, how can we find the velocity from the acceleration time graph, velocity of the body? To find the velocity of the body, let's say if a body is moving with constant acceleration, 0 t acceleration. Constant acceleration means what? Now, constant acceleration means the body has some value of the acceleration a, let's say, and it continues with the same velocity, same acceleration. all right, with the time. It remains constant with the time. So this is the graph for the constant acceleration. This is also non-uniform, constant acceleration of the body. Okay, so the body acceleration remains constant with time. Now how can we find the velocity of the body from this graph? We know from the first equation of motion that v equals to u plus at, right? Now when u equals to 0 means the body started from 0, v equals to what? Simply at, right? Now here if the final time is t1, let's say this is t1, o, a, b, c, the acceleration is a, of course, then what is the meaning of at? A is the length of the rectangle OABC, right? And breadth of the rectangle, and T is OA, which is the length of the rectangle. Means AT is what? AT means area of the graph, area of rectangle OABC. That means from the acceleration time graph we can find the velocity of the body simply by finding the area under the graph. Okay, so these are the things we have talked about in this lecture. I hope you have learned a little bit from this lecture. If you have any queries or suggestions, please write in the comment section, and I'll try to answer all the questions in the next video. All right, so see you in the next video. Till then, take care.